after having learned already how to define your own benchmarking problems and defining your own optimizer and maybe hand it over to Hydra. If you're not a big fan of Greek mythology or maybe want to do anything else which is not directly tied to Hydra, but this is not what I pressed, or just want to do any kind of computational experiment. Yeah? I mean, you're all here to learn about HPO and AutoML, but maybe you also want to do other computational experiments, just evaluating some function computationally on a distributed system. Then PyExperimenter might be a choice for you. And I would like to motivate this a little bit. So you're sitting there in this office at your university, at your industrial institution, and hopefully trying to tickle your brain cells to develop a new algorithm, which is hopefully also state of the art, but you need to find out, of course. How do you do that? Well, you specify a list of experiments and you send that over to an HPC system, which can then carry out all these computations in a highly parallel setting so that you don't need to wait for years or months for your results, but maybe have it the other day. No, I don't want to install any updates right now. Thank you. All right, so what happens typically is that some of these experiments will crash. And I used to specify these lists of experiments literally in terms of lists. Yeah, just picking indices of that list, and then poor me was sitting there finding all the indices of the crashed experiments and then just removing the successful ones from that list, which is pretty tedious work. So I looked like this smiley, fixing the bug, but then also trying to rerun parts of the experiment and resubmitting this array job, and maybe eventually this all turns out to work. But just working with these kind of lists does not really scale. Yeah? And this is why we developed PyExperimenter, and PyExperimenter basically allows you to easily, handy specify this grid of experimental parameters you would like to define. It facilitates parallelization and distribution of the experiments by having a database at its core. So either light SQL if you're just working on file systems, or you have a distinct database server which every node of an HPC system can access or can get access to. And PyExperimenter serves as a kind of interface here, just really facilitating with a very easy to use interface this entire setup. You just need to have a database server running and PyExperimenter being connected to that database. Everything else will be captured by PyExperimenter itself. Why is that desirable? Well, if I now see that experiments are crashed, which is automatically logged by PyExperimenter, you can just reset those rows in a database and simply rerun your script with a reduced size, so you don't need as many jobs anymore, because you might already have some successful experiments, and then that's it. It's also cool because you launch the same dump script at every node. Yeah? So you don't need to distinguish between the jobs. You just deploy the same script everywhere, and it will just automatically communicate with the database, pull an experiment description, and compute that stuff and write back the results. So how do we use it? Well, first of all, we need to define a function which compiles an experiment setup into the result values and just gives this then later on to a callback function. So this is your interface. You get the specification, and you have a function you just call providing the results. What else? Well, there are configuration files where you define the experimental grid and the database connection, of course. Yeah? And in the experimental grid, you basically define keys for your experiment that span the evaluation grid and result fields which you would like to communicate back. And then you just need this executor now. So instantiating PyExperimenter with your run function and the configuration files, and that's it. And down here, you can then even say how many experiments one such script execution should take care of, either infinitely many, so -1, or a certain number of experiments. So how does this workflow look like then? Well, first of all, you create the config files defining your experiments. So this you will need to do anyways. Then you set up the database table with PyExperimenter. You just call the function fill database table by config. And then you implement the run function, start your experiments. And in the meantime, you monitor your experiments already. Yeah, you can see how many jobs are already finished, which are still processing, which have been failed, which have failed. And if there are fails, you will also have directly access at these rows to the stack traces. So you can even simplify debugging. If you have thousands of log files, you have everything already in place here in this database. And then you can also alter the experiment setup, restart experiments, and eventually you have a nice table in the database exhibiting all your proper information you would like to analyze. And PyExperimenter also gives you an interface for that, just pulling the entire information into a pandas data frame, and then you can go on with your data analysis. So this is joint effort of all these cool people here who helped to implement this library. And there is also a paper describing the working principles of PyExperimenter on a more abstract level. I put myself into parentheses because I don't have a single commit on that repository so far. I just did some kind of crocodile management in between, expressing my desires, what this library should be supporting and whatnot, and that's why. All right, so it's time to get started. So we have like 15 minutes now. So I hope you all can execute Python, so Jupyter notebooks locally. Otherwise, I would recommend that you just load them in Google Colab. Should be easily possible. So if you take this URL, you will get this template Jupyter notebook. Up here, you will have access to the documentation. So we try to be really generous in providing enough documentation. And in case you have questions, of course, you're free to ask. I would just, okay, this, I need to stop before I can slide over. Okay, so how this looks like, well, it's really a step-by-step exercise, and it starts with really, really simple to do. So every one of you should be very much capable of finishing this tutorial quite quickly. However, it's a little bit more extensive, so it won't be enough time today. But take this home. I will also give you the solution, but it is more helpful if you do it all yourself. It starts with implementing a run method and specification of an experiment setup configuration. And once you've done this, you fill the table, and you can then already execute some stuff here and already see what happens. So if you make it to do item 6, it's already good, because at this point, you already executed your first experiment. Yeah. So happy coding, and ask your questions whenever you have them. Maybe you can still take it home with you and try it out. I can definitely recommend it. To cite a very smart person from last year, she said that such tools can transform lives. Yeah? And for me, it was definitely life transformation, from tedious indices sorting to really high-level monitoring of jobs. And I can only recommend to use such things, and trying to automate as much of your research pipeline as you can. Yeah, so not only machine learning application engineering should be automated, as we believe, but also your research pipeline, conducting experiments, generating plots, and so on and so forth. Every step you can automate in that process is really helping you in producing results faster and reiterating over things. If you just by hand generate plots, and you notice in the end that these results are messed up and you need to rerun the experiments, you sit again there regenerating these plots manually. This is what you don't want to have. Yeah? The best thing I can recommend is to really have everything on the press of a button. So first of all, this facilitates reproducibility for your research. So you can also provide these kind of scripts to readers of your paper or reviewers of your paper who can then generate the same plots for your data or for a re-evaluation of your data. And it's just win-win. Yeah? So just do it. All right. So one last thing. So first of all, here are the solutions. So if you want to take this home with you, I will also put the slides, of course, into Discord, so you can also access this later on. But here you can then see that it's really low effort to set all this up. And typically this run function you will need to have anyways, and the rest which you need to wrap around is not that much anymore, and it helps a lot. All right, one last feature which I did not tell you about so far is the following. So first of all, PyExperimenter also allows you to measure your carbon footprint while doing experimentation. Sounds, first of all, strange, but as we all know, we face a climate crisis, and we also should be aware of how much we consume. And PyExperimenter will actually measure how much energy draw you have, or at least estimate it, and then also, depending on your local region, compute a carbon footprint. And you can just summarize these statistics for your own. They come for free, basically. Yeah? So PyExperimenter will do this anyway, unless you toggle it and deactivate it. And the second thing here is that you can have logging tables. So HPO algorithms are typically of an iterative nature. So you have intermediate candidate evaluations. And if you want to determine your anytime performance, you also need to access that kind of log. And PyExperimenter basically allows you to also have these in terms of tables, which will then automatically be related or pointed to your experiment table entry. So you always have your data stick together, which is quite nice. And you have a quite easy interface where you can just throw in dictionaries, logging your stuff, and the rest is for free then. All right. With this, I release you into your well-deserved break and to your new caffeine dose. And I hope you had some fun. And if you have any questions also after the summer school, please don't hesitate to reach out to me and ask. I'm always happy to help in using PyExperimenter. So thank you.